30. A 1,300 kilogram roller coaster starts at rest at the top of a 60-meter hill. Track goes down to the ground before going up to a second hill with a height of 35. There is no friction. Draw a picture and find the fast the coaster is traveling at the top of the second hill. So, first things first, draw a diagram, knowns and unknowns. Okay, do that first, see what you can come up with. All right, diagram. 60-meter hill. Down to the ground, 35-meter hill. Okay, let's see if you remember. What is the one thing we have to do on these problems, besides draw the picture and knowns and unknowns? What do we have to do? Yes, this is an excellent start. What do we have to do? We have to pick something. We have to pick where 0 is. And I'm going to go ahead and say the ground is 0. Now, you don't have to make the ground 0. What else might be a good spot to make 0? The 35. That would be another good place to be 0. Most people do it this way, so this is the way I'm going to do it, but you absolutely could do it the other way too. Okay, so now we do our knowns and unknowns. So the mass of the roller coaster is 1,300. The height at the beginning is 60 meters. The height at the end is 35 meters. It said it started from rest, so the initial velocity is 0. The final velocity is how fast it's going at the end, which we don't know. And it said there's no friction, so the work is 0. So there's my knowns and unknowns. So now we got to figure out what equation to use. So this is talking about motion change, specifically how it's going from one point to another. Okay, this would be possible to do momentum with, but it's going to get nasty. It's going to get real nasty because we're talking about height changes, and that's just going to. Okay, so that would not be fun. However, what we can do is talk about how work causes an energy change. So work equals final energy minus initial energy. And the final energy is just kinetic plus potential. The initial energy is just kinetic plus potential. So this is the equation we're going to use. So we need to find all this stuff, though. So work is 0. There's no work being done. But now I'm into the weeds here, right? Because I don't know the kinetic and potential energies, initial or final. That wasn't any of my knowns and unknowns. So I got to find those.
Why is work 0?
Because it said no friction. Okay, I want to see if you can figure this part out. See if you can figure out what goes in there. Again, here's the equation. We found work to be 0. So see if you can figure out what goes in there. And if you're having trouble, call me over and I'll help. But see if you can figure out. All right, let's be like Mortal Kombat. Finish it. So here's where we are. So we're finding all these energies. So we find kinetic energy initial, potential energy initial, kinetic energy final, potential energy final. So the kinetic energy initial is 1/2 times m times v squared, which is 0. So the whole thing goes to 0. The potential initial is mgh. G is 9.8, not a negative 9.8, it's just positive 9.8. So that's 764,400. KE final is 1/2 times mass times velocity squared. I do not know what the velocity is, so I'm just leaving it as V. So half of 1,300 is 650. And P final is mgh. Which that gives you 1,300, 4,459. So now we just got to plug the things in. So final kinetic plus initial, so 650 V squared plus 445,900, and then 0 plus 764,400. So this is going to be a negative number, so I'm going to subtract that from this. Gives me 0 equals 650 V squared minus 318,500. I'm going to add the 318,500 to the other side. Sorry, 650 V squared. And then I'm going to divide the 650 over. That gives me 490. All I got to do is square root that number. And I get 22.1. Okay? That's where we'll stop. We will do a couple more next time.